2.7 continued. I'm still going to go on my symmetry tangent for one more video. Okay, then we'll get back to our last transformation. But there's one more other type of symmetry, and it's called symmetry about the origin, or origin symmetry. Okay, in that case, that's kind of like, you can almost think of it as being symmetric across the x and the y, just sort of at the same time. Okay, so what I mean is something like f of x equals x cubed. Okay, so it says, hey, if x, y is here, then it's symmetric about the origin for every xy. If for every xy, we also have negative x, negative y. Remember, we saw that specifically with 2, 8, and negative 2, negative 8 with the cube function back in 2.6. And that will be true for any points. Okay, so just because these 2 points are on here doesn't mean it's necessarily symmetric about the origin, because it could do something like this and just happen to hit that. So that's why when we check this, we really want to check it algebraically. So I'm going to check this, x squared plus y squared equals 9. Okay, you can check for x-axis and y-axis symmetry. I'll let you do that. Let's look at what this thing looks like. This is a circle with radius 3, centered at the origin, if you remember from one of our earlier sections. So it looks something like this. So it's not hard to convince yourself, graphically anyways, that if x, y is on this thing, I think negative x, negative y is also on this thing. The key is it's centered at the origin, 0, 0. But let's check it algebraically to see if that's actually the case. So for the origin, I know I have to switch the x's and the y's. So I have negative x squared plus negative y squared is equal to 9. And in both cases, I know that a negative value squared is the same as the original value, non-negative, squared. So both of these are the same as x squared plus y squared equals 9. It's the same. That tells me I have origin symmetry. Okay, so those are the different types of symmetry you'll see with some of these. Now, we're going to extend on that by talking about even and odd functions. Now, even and odd functions, really, they're graphs. It's like looking for symmetry about y, right? And symmetry about the origin. It's really the same thing. It's just a more convenient shorthand way of doing it. Okay, so why don't we talk about symmetry about x? Well, remember we said symmetry about x, if I had something like this, wouldn't be a function. So I can't have some sort of functional notation for that. Okay, so let's read the definitions and we'll see some examples. A function is an even function if f of negative x is equal to f of x for all x in the domain of f. Okay, so essentially they're saying it's symmetric about the y-axis. Notice, if I have x and f of x, that means that if I have negative x, I have f of negative x, and these are the same. F of negative x equals f of x. That's what we're saying right here. And that will be true for all x, right? That's key, all x. So we're going to be able to check that algebraically. The second type, a function is an odd function if f of negative x equals negative f of x. So the thing I want you to notice is, notice in both of these cases, to check, all we really need is f of negative x, and then we'll get our answer. So it can't be even and odd like at the same time. I suppose in some ways it could, but that's beyond the scope of what we're doing. And that's equal to negative f of x for all x in the domain of f. So that's the same as saying symmetric about the origin. So notice that if I have x and f of x, then f of negative x, okay, so right here is going to be equal to negative f of x, okay, and that's here. So this would be your f of negative x, and here we would have negative f of x. Okay, so it's the same thing as checking for symmetry about the origin. So in both cases, when I want to check if a function is even or odd, I'm going to just check f of negative x and see if I get out f of x, if I get out negative f of x, or if I get out nothing. Okay, the reason we care about this, especially when we get to trigonometry, this is very, very, very useful for us to figure out what's going on with some of these trigonometric functions. So We do want to know a lot about even and odd functions. Example, determine if each function is even, odd, or neither. So looking at this function, in both cases, I want to check for f of negative x. So if I do that, that's going to be negative x to the fifth minus 2 times negative x cubed. Now, here's the thing. If I have negative x to the fifth, here's what I want you to ask yourself. If it's a negative number, okay, and it's raised to the fifth, what is it going to be? It's always going to be, it's always going to be negative. So I can replace it with just negative x to the fifth. So just take the number to the fifth, make it negative. For example, what I mean is if I have negative 2 to the fifth, I know for sure that that's still going to be negative, and then it's just going to be 2 to the fifth is 32. That's what I'm doing right here. Then I have minus, okay, and anything cubed, if it starts off negative, is still going to be negative. So negative and then x cubed. So that'll be just like this. So I have negative x to the fifth plus x cubed, the double negative. And the thing to notice here is this is really the same as negative x to the fifth minus, I forgot my 2, I'm sorry, 2x cubed, which of course is the same as negative f of x. So I went from f of negative x and I see, oh, that's the same as negative f of x. For that reason, I know this thing has symmetry about the origin, or just to make it simpler, this is an odd function. Okay, so that's an odd function. How about this one right here? Let's form f of negative x, and let's see what we get here. Well, that's negative x to the fourth minus 5 times negative x plus 8. That's going to be, let's see, a negative value to the fourth. That's going to end up being the positive version of that, plus 5x, because I got a double negative, plus 8. And it doesn't look like that's equal to regular f of x, because I got the positive here. And if I put a negative out front and it flips all the signs, that's not equal to negative f of x. So I'm going to say neither in this case. Okay, so everyone see what I did here? I think I forgot to move the page up when I did that.